Hello, my name is Doliner, and today I'll be presenting the circuits for experiment. So we begin with circuit 5.1. Over here we can see that our pin number 5 on the board is connected here to the switch, which is switch 6, just for convenience because it's closer. Now we have 7 also, which is connected by this red cable here, which is our K input, is pin 16 on the board. And then we have our clock connected to the logic switch over here at pin 1. We have everything powered up over here because of the clear and preset asynchronous inputs. So we just power them up. Here just comes regular power, so VCC power to the board, and also grounding it over here. Then our outputs are being shown over here by this LED. Here is our Q by this black cable and our not Q. So when we see how it operates, we will see that when we switch them both off, when we make clock transitions, it would do nothing. When we just put, sorry, this is clear. So when we use K, we see it turns off, it stays like that. And again, if both are off, it stays like that. If we switch both on, we see it toggles. And then that's pretty much it for this circuit. Now we start with figure 5.2. For this figure, we have our data switch connected here to pin 4. Then this input is then inverted here on chip 7404. Then the outputs come into the K input on pin 16. Everything is coming here to both LEDs, so this is not Q, this is Q. So everything's powered up here. We have our clock connected to the logic switch, and yeah, everything powered and grounded. Now let's test it out. So as we said on the assignment, it turns into a D flip-flop, so whatever the input is, when the clock transition occurs, it's gonna switch. Now we start with figure 5.3. For this, we have the logic counter. So as said on the directions, we have all of our switches here on high, and then going to the pre and clear inputs here on the chip. We have our logic switch connected here to the first pin. As I said before, the asynchronous inputs. We have J and K connected to power. Then we have the chip getting power and the chip getting grounded here on the gray cable. Afterwards, we get the signal from J. It's coming back here as an input for the clock on the next logic gate. So let's take a look at how this behaves. So this is just a clock counter in binary. So every time, now we are at 0, so 0, 0. When we make a clock transition, we get 0, 1, which is 1 in binary. We get 2 in binary, so 1, 0. Then we get 1, 1, which is 3. So that's it for this circuit. For last, we're just testing the last question conditions. So we just switched out the logic switch here to our data switch. Now when we toggle this clock signal, because this is bounded system or bounded switch, it creates a random signal, so it does not work as intended. And when we switch our clear input, we just see that it stays off, and whatever we do to it, it doesn't work. Likewise with this one, it just turns on and it does nothing afterwards. It just stays as we intended. So this is just turning it off, and this is just turning it on.